I'm in SPSS looking at the hand group dataset, and I'm just going to look specifically at testing the assumption that the variance in each group is approximately the same. Now we can see this on the graphs. Let me go down to just doing a box plot. So the variation is about how much spread there is in the data for each group. Now this is an odd data set in that we have these outliers, and this is going to increase the variance in the groups that have them. So this one will have a large variance. This one here is fairly consistent with no outliers, and this one here is mostly consistent apart from these outliers, so this will have a larger variance. And then we can see that these data points are quite spread out as well. We can get the variance estimates in our descriptive stats, and you've probably looked at these for other things, so average hand grip strength and arthritis. It's not friendly to look through, but you can go through and look at the variance here. So that variance is 168, it's huge, and this variance for number 2 is just 14. So it's a little bit fiddly to go through and pick through these. And there's one other graph I'll show you. If we go to the ones that we've been using for the errors, the confidence intervals with error bars, the mean with the confidence intervals as error bars, you'll see here that we actually have the option to change the mean to variance, click apply and OK, and here it's going to give us the just one symbol for each of the variances. So we see the variance is high for group 1, low for group 2, this was the one with no outliers, high for 3, and 4 was the one that was quite spread out. So that's just having a look at the variance, and I wouldn't normally need to see a plot of testing this assumption of variances, but if you're having trouble getting your head around what we're doing here, it might be nice to plot them out. Now when we actually did the test of means last week, it came up with the test of variances whether we asked for it or not. So the independent samples t-test, we did the average hand grip strength grouped over gender, and it came up here with the Levine's test for equality of variances. Now the null hypothesis for this is that the variances are equal. We have a high p-value here, so we have no reason to reject that hypothesis, and therefore we will assume that the variances are equal between the groups. And that means we'll use this first row here for the t-test with the variances assumed equal. Now for the analysis of variance. I'm just going to go through these options. Okay, here it is. Hidden away under options, we've got the homogeneity of variance test, and this is the same test, Levine's test for equality of variances. Now why it doesn't tell you that that's what it's doing, I really have no idea. Homogeneity just means that they're all about the same. If they were all different variances, then that would be called heterogeneous. So homogeneity of variance test means that it's testing to see if all the variances are the same. So we've ticked that option, continue. Okay. So now when we do the one-way ANOVA, you can see that we've got this extra box here for the test of homogeneity of variances, and here it does say the Levine statistics, so it's doing approximately the same thing that it did up here. The null hypothesis is exactly the same, and that is that there is no difference between the variances, or that the variance in each group is the same. We have no reason to reject that we've got a high p-value, and therefore we can assume that the variances are equal and continue on with the analysis of variance. So I guess the question here is, what do you do if the variances are not equal? Do you still do the test? Well, it depends. It depends how far not equal they are, and there's a few more advanced diagnostics you could do to see if it matters, which we wouldn't cover in this subject. So as far as it goes for this course, you would still continue with the test, but you would need to add a little caution into your results, saying that these results must be interpreted with caution due to the unequal variances. And I've read plenty of papers where they've found that the variances were not equal and they still went ahead and did the ANOVA anyway. Now, as it happens, ANOVA is what we call fairly robust in that even if you violate the assumptions, it still holds up pretty well. It usually does a very good job, even if your variances are not quite equal and your data is not quite normal. It's a very handy procedure for looking at differences between groups. So for the most part, unless there are really huge problems with your data, you would still go ahead and continue with the analysis of variance, but you do want to acknowledge the fact that your assumptions have not strictly been met.